otherwise the yield would really be lower because we are reducing the solids by 20%, yet I'm getting the same amount of gas produced. Well, these are my results. If I use my overall yield, destruction of volatiles, is 24%. Total solids, sorry. If you add the total process, so the 20% from the worms and the reduction in my anaerobic batches, it's 36%. So it is a significant increase, 50% as I said. But if we measure the reduction in Friesland, in the storage tank, it's 60% instead of 36%. So there is methanogenesis is not the only answer.
And there's another difference because our reactor is at 10 degrees or 12 degrees and your experiments are at 25 degrees, so you have double activity.
Even that, but in the summer it's also 20. In the summer, okay. I did a lot of, for me, I'm not even going to mention it, but I calculated the rates, they're all the same. And I didn't see an improvement at low temperature in my because I also did 7 degrees. It could be too cold. Okay. So this is the main question: why do we have 60% reduction of solids in our storage tank in Friesland? And we have 36% in our batches here. So we don't know. And that was my presentation. Except for the recommendations.
How do you detect solids? Because that is the main parameter of your main result. So it's important that you measure it in the right way.
Yeah, I had a slide, but we removed it at the end. But then we go to the process. It's measured by light sensors. And those are checked with by incinerating and drying it, so they should be correct. Mm-hmm. And I can remind.
Because I can explain you why I asked this. Because of course, if the worms make colloids from your flocks,
meaning smaller particles?
The colloidal particles are really small. They make the size of bacteria.
Yeah.
And that's apparently what they are doing. They are very good shredders.
Yeah.
Just a shredding machine.
Yeah.
So and then it's not so easy to for example, to sediment this colloidal particles. And if you detect your solids by centrifugation and by weighing, then you can underestimate it.
We have our own reactor. This is measured by light and checked. What we do is a large volume of water is introduced, and we settle it, and the water effluent here is measured. Mm-hmm. We are having problems in this aspect because it would be correct if we had a difference, if a lot of salt would go into solution and all the salts and small particles would leave. Mm-hmm. But we did not find this big difference. We found a small difference.
So actually the evaporability is a lot better of this sludge, so it settles quicker for some reason. Okay.
Yeah, but these small colloids, those you won't even see by eye. It will be clear.
Yeah, but they still scatter light. So in principle, you can see, if you measure it in this way, then you still should see them.
Yeah, but we are measuring what's coming out of the water here and what's left, and we are basically missing, a lot. So we are missing something, or something mysterious is happening.
But it cannot be accounted for the worm biomass.
Well, those are eventually washed out into the.
Also into the solids.
Yeah.
Okay.
Yeah.
They die instantly if they.
No, but you know, of course, that the conversion efficiency of eukaryotes is very low. So of course you are losing your organic to CO2. You have also carbon balance.
Yeah.
The problem is that we cannot close The carbon balance.
Yeah, but that's exactly where you're losing your solids also, at least
There
volatile.
might be a huge amount of CO2 that is produced in the worm reactor. Is that
No,
where we are missing?
no, but it's a pyramid. It's a huge pyramid when you go from, let's say, from bacteria to animals, and the efficiency is decreasing very much. So they are not as efficient as bacteria can use up to 50% of the substance.
That's not the problem.
And the yield is about 25%. So if you eat 4 kilograms of sludge, you produce 1 kilogram of worms. The yield is 0.25.
Okay. Which means that this sludge is really purely organic stuff.
The sludge is about 70% organic.
Yeah, but at the end, in the beginning, in sludge is 70%, and what is setting after the worm reactor?
It's the same.
It's the same.
It's the same. So there are some inorganics going into solution, or they're going into.
What is known about the earthworm? What are they doing?
The first, sorry?
Earthworms.
Earthworms.
The one, because it is known that it's a factor of soil fertility.
Yeah.
So what they are doing with soil when they are eating soil? What they are doing?
They're introducing air and they are making the area smaller for.
Yeah, but not only. They also add a kind of a slime to the soil aggregate, and so they structure the soil in a much more favorable way for oxygen penetration.
Yeah.
So they are introducing something in the particles. Kind of what we do with saliva also. I mean, it's also kind of fertilization or whatever it is.
But whatever the worms are doing, it's not why we have this problem. Because I don't know what happened here.
Yeah, but it can be that they make the sludge more accessible. Anyway,
sorry, what?
now you are my student. This is for Dimitri. They are in the same family as earthworms.
Yeah, I see. Yeah.
I'm sorry. Now
No,
you can do
it's
it.
okay. Oh.
But what if you make a physical comparison of the sludge which is coming in and which is coming out?
Yeah.
Just make a, let's say, electron microscopy of these particles, or even